find. But just for the sake of completing everything, let's fill out the entire chart. So this is in parallel, and it's a really simple parallel circuit. So we know that 120 is the voltage for everything because it's just 1, 1, and 1. Simple as that. The currents, on the other hand, are going to be different, and the resistances are going to be different. In order to make this a little easier and to solve for the variables directly, we're going to use a couple of the other equations on the equation sheet that relate to power. There is the equation where power is equal to the voltage times the current, and there's also one where it's the current squared times the resistance. There's also the voltage squared divided by the resistance. So first things first, let's just find the currents for all of these, and then we can solve for the resistances. So we're going to take the power, so 1,650 divided by 120, and so that means that the current for there is 13.75. Do that for the next one, so that's 9.08 and 10.41. And so those are the currents for all three of the appliances. And we can use that to help find the resistances for all of those. So the resistance, you would just take the voltage divided by the current like we've been doing. So that's 8.73. That's 13.22. And that is 11.52 ohms. And if we were to put all of those in the fractions and use the total resistance equation for a parallel circuit, we would end up with the 3.61 ohms. Alright, so now we just have the last problem, so we're going to just keep on going. And now for number 10, we are given this circuit that has 6 batteries wired up like this, and each of these individual batteries has 1.5 volts. And what we're supposed to do is find the current supplied by each one of these individual batteries. Now when you think about this, there are 4.5 volts of power along here and 4.5 volts of power along here. And since it's 4.5 volts and it's in parallel, only 4.5 volts is moving out from this collection of batteries. So it's almost as if one row didn't exist. What we're going to do is basically just put 4.5 volts and just go from there. So, next thing we're going to have to do in order to find the current is to condense all of this into one resistor and find the equivalent resistance. So if we combine the 6 and the 12 ohms, we get a 4 ohm resistor, and then another 4 ohm resistor. And then if we add the 3 and the 5, well, we've got the 3 ohm and we've got the 5 ohm. And then if we add those together, we've got 8 ohms and 8 ohms, which condenses to 4 ohms. So for our equivalent resistance, we have 4 ohms, and I didn't fill out the resistances initially, but we have 6 ohms, 12 ohms, 4 ohms, 3 ohms, and 5 ohms. From here, all we have to do in order to solve for the current throughout the entire circuit is take 4.5 divided by 4, and the answer we get is 1.125. Now, there is one problem with that. 4.5 volts is the amount or is the voltage put out by 3 batteries, and there are 6 batteries total in this circuit. So what we end up having to do is take this number, which is the current put out that would be put out if there were only 3 batteries, and divide it by 2 in order to get the current put out by every single individual battery. So we've got, if we divide that by 2, what we end up with is 0.5625 amps. And that is the final answer, but we're going to keep going and solve the rest of everything. So if we go on, and we've got 4.5 volts, the voltage splits, so we've got 4.5 up here and 4.5 down here. What we're going to have to do is find the current along here. So 4.5 divided by 8, and that gives us 0.5625 and 0.5625, because the currents are the same across this one and this one. And then if we just multiply these values together, their currents and their resistances, we get 1.68 or 1.69 and 2.81. And I believe that's 2.81. And again, that's just with rounding. And up here with our 4.5 volts, we also have the same current because it's also, we can condense it as well to 8 ohms on the top as well as on the bottom. What we can do is find the current across what would be this resistor, which splits into these. So once again, we end up getting 0.5625. So along this entire stretch, the current is equal, or the current is equal to 0.5625, which means that at this point the current is that, but at these the current is different because the current splits. So what we have to do is find the voltage at this point, or we can just find the voltage of number 3 and subtract that from 4.5. So I'm just going to do that. And the voltage we get is 2.25, and when you subtract that from 4.5, you actually get 2.25, and since the voltage here and the voltage here are the same, you can put those values in for both, and then you can solve for the currents. So that's 0.375 and 0.1875. And from here, let's just do the power and be done with it. So the power is 0.84 and 0.42, 1.27, 0.95, and 1.58. And if you add all those together, you're going to get around 5.0625. Once again, it's just the rounding errors that keep you from getting exactly that number. So once again, we were trying to solve for the current the current from every single individual battery. So what we did was we found the current put out by 3 batteries, and those batteries were only using their voltage. And then we basically divided by 2 to account for the other 3 batteries. So this has been another tutorial. As always, I hope that these helped you out and helped you to understand more about this problem bank. If you have any questions, comments, or concerns, either fill out the form on our website or send us an email at bestudios.physics@gmail.com. Good luck with this problem bank. See you next time.